Okay, so I have the parent functions right here graphed. This is y equals 2 to the x. I have the points that I was talking about right here, showing you that it passes through. Since my b value right here is 2, then it's going to pass through 0, 1. Again, it's 1 because my a value is 1. If you don't see it, you can understand that it's there, because notice it didn't change my graph. So that a value is 1. When you don't see an a value, a is an understood 1. So my a value is 1, so my 3 points are going to be 0, 1, 1, 2, and negative 1, 1/2. I put this b value right here under 1, and 1 over 2 is 1/2. So those are my 3 points. Now what happens when I change the a value to a negative 1? It's going to cause a vertical reflection. And all of these values right here that becomes a negative 2, that becomes a negative 1, and that becomes a negative 0.5. So all of those y values become negative. So a negative a value changes the y values. What happens when this should be, I meant to have this up here. Hold on, give me just a second. When you type in a c value, you have to put it in parentheses, or Desmos will automatically make it a d value. So here I have graphed, this one's going to be, you should be able to predict that this, you see a +3, that means that the c value is -3, so it's going to shift left. So you should be predicting that all of these points right here will shift left 3. So I'm expecting this point 1, 2 to instead be -2, +2. So let's turn that on. And we see right there it did. This graph right here shifted from 0, 1, it shifted 3 units to the left. This graph right here shifted 3 units to the left. And so now it's at -4, 1/2. Okay, what did we do to each one of the x values? We subtracted 3 from it. You say 1 minus 3, you end up at -2. You say 0 minus 3, you end up at -3. You say -1 minus 3, you end up at -4. So having a c value of -3, you have to remember what you're actually what's going to be visible, or what you're going to be looking at, is an x plus 3, but you know that's a -3. I'll turn that one off. So what's the prediction here? I'm going to flip it over the x-axis. That's what the -1's going to do. And this should shift everything, including my asymptote, down 3. I forgot to include an asymptote, so let me put one in here right quick. Let's add an expression. Let's do y equals -3. So I'm predicting that's where my asymptote is going to be, and let's make this be a dotted line since that's how we're used to seeing the asymptote. And now let's turn this one on. We're expecting it to reflect and then shift. So let's see if that's what we see. Absolutely. It reflected down and then everything shifted down 3. So my range on this one would be different. My range would be -infinity to 3. My domain is still all real numbers. My end behavior on the left side, I'm going to be approaching -3. On the right side, my graph is going to -infinity. My y-intercept is -4. It was -1, so I shifted down, and then I changed the sign. So I said +1, changed the sign and made it be -1. And then -1 minus 3 get me to -4. So that accounted for all of the pieces parts that you have to do. And again, it wouldn't be any different. Let me turn all of this off. It wouldn't be any different if I had the base 10. There's what base 10 looks like. There's the 3 points. There's the 3 points, 1b, 0, 1, and negative 1, 1 over b, because 1 over 10 is 0.1. So there's the 3 points, and the transformations behave the same on this parent function as it does on all the other ones. Turn that one off, and you can see the e function. There's the 3 points. That's 1 comma e, and e is 2.718. There's the 0, 1. And then this is what I showed you. I told you I would show you just a minute ago. This, if you look at this, I can show you what this looks like, how I actually have it typed in. I have it typed in as negative 1 comma 1 over e. Well, you do 1 divided by 2.718, and evidently you get 0.368. But those are still those same 3 graphs. And the transformations of these graphs work the same as if you change a to a number bigger than 1, you get a vertical stretch. It became taller. If you make a be a decimal, a fraction, it gets shorter. It's a compression. Okay, it got closer to the x-axis. When it's a compression, it gets closer to the x-axis. When it's a stretch, it gets farther away from the x-axis. Okay, when you see a transformation that's in the exponent, you know it's going to be a horizontal shift. You see a +4, so you know the c value is negative. It's going to go left. And when you see a d value, a number added or subtracted at the end, you know that's going to change the asymptote and shift everything either up or down. So -1's going to make it go down, +1 would make it go up. So the transformations are all exactly the same as they have been for previous functions. They're all the same, and you should now take a few minutes to fill this form out. I will come back on with mine filled out, and you can include the examples that I did on the video to write these down, but you should know how to fill this out. So stop the video and fill this out, and then we'll come back and make sure that we've got it filled out right. So when you see this symbol, the absolute value symbol, that's just a way for me to say ignore the sign of a. In other words, I don't care if it says -3 or if it says +3, since if you ignore the sign, 3 is a number that's bigger than 1, then you know you have a vertical stretch by a factor of a. What's actually happening is the graph is moving away from the x-axis. It's taller. And all of the y values have been changed by multiplying them times a. So if the original y value was 0, 1, it's now 0, whatever a is, times 1. So for example, this one would be, the y-intercept would be 3, the y-intercept would be 4.5, the y-intercept would be 9.5. All of these examples are numbers that are bigger than 1. It can be a whole number, it can be a decimal, and it can be a fraction as long as it's an improper fraction. 9 over 5 is a number that's bigger than 1. All of those would be vertical stretches. This is a vertical stretch by a factor of 3. This is a vertical stretch by a factor of 4.5. And this is a vertical stretch by a factor of 9 over 5.